Welcome to the NPTEL online course on fractals and multifractals. So, in the last lectures, we have constructed the fractals interpolation function by using some special type of iterated function system which consisting the mapping Li and Fi. So, in this lecture, we will understand the parameters of the Li and Fi functions, then later we will generate the fractal interpolation functions by estimating their parameters. In the last lecture, we have constructed for the given set of data point xi and yi, we have formed the interval x1 to xn, which we call it as I, and for A we are taking less than the minimum of yi, and B we are taking the maximum of yi, then we form the interval a comma b, then this x is taken as the product of x1 to xn cross a comma b, that means I cross a comma b. We are taking this rectangular region, the compact set. That wi, we are defining wi of x comma y as li of x and fi of x comma y, where this Li is a mapping from I to II, where II is xi to xi plus 1, where this Fi is mapping from x to r, the x is defined here. Then this Wi is a mapping from x to II cross r. Since the Li mapping to II, therefore this Wi map to x to II to r. Now, this Li we have taken as a contraction which controls the x direction. Fi we are taking as a contraction with respect to the second variable which controls in the y directions. Then we define the f of b as the union of this all wi's, then we will form the Hutchinson-Bansley mapping. Then we proved that this Hutchinson-Bansley mapping has a unique fixed point. That fixed point we can call it as g of gg, here we can maybe call it as g, which is a graph of a continuous function which passing through the given set of data points. That means this is the graph of the continuous function g, where g is the continuous function which passing through the given set of data point. That means the fractal interpolation function is obtained as a graph of a continuous function which passing through the given data points. That graph we can obtain as a unique attractor of the special type of iterated function system. Now, that iterated function system x with this wi, here wi consisting of Li and Fi. As we discussed, Li in the form of Li of x in the form of Aix plus Bi, where this Ai compress the whole interval to the subinterval, and this Bi is shifting the interval to the right so that the endpoint will match, and this will satisfying Li of x will satisfying the endpoint condition Li of x1 equal to xi and Li of xn equal to xi plus 1, and also this Li is a homeomorphism function on I to I to I, this Li is a homeomorphism function, that means bijective and bicontinuous. Now, for this controls the x direction, for control the vertical direction we created this Fi. This Fi also satisfying the endpoint condition Fi of x1 and y1 equals xi, yi, and Fi of xn and yn we can write as yi plus 1. Now, the iterated function system generated for generating the fractal interpolation function, the most widely used the iterated function system of the form, this Li of the form Aix plus Bi, this is very obvious one, and this one Fi of x comma y equal to alpha I of y plus qi of x. In the Li of x we have the two parameter ai and bi. This ai compress the whole x interval into the sub x interval, and this bi shift to the sub interval towards the right so that the end point will be matched. So, this is the role of a and ai and bi, that means the parameter a and b. Now, here we have the alpha I and qi of x. Let us discuss what is the role of this alpha I and qi. Since this Fi controls the vertical directions, then what is the role of this alpha I and qi in the controlling the vertical direction? Here this alpha I, for each interval we know that in each interval we have one alpha I, then this alpha I is must be less than 1, the modulus of this alpha I must be less than 1. This family alpha I for I equal to 1 to n minus 1 number of elements is a family of parameter named as the vertical scaling factors, and this one alpha equal to the set of these numbers alpha 1 to alpha n minus 1 is called the scale vector. Then we know that this Fi, while constructing the iterated function system for generating the fractal interpolation function, this Fi we can consider as a contraction with respect to the second variable. That means Fi of x comma y and minus Fi of x comma y dash. If you are finding the distance between these two number, one can get less than Ri of y minus y dash, where r is greater than 0 and less than 1. Now, we have this form Fi, we are taking this form f of this form, that means Fi of x comma y is defined as alpha I of y plus qi of x. If you are finding for the two number, if you are finding this one, that means Fi of x comma y minus Fi of x comma y dash, if you are found to find the distance, you just apply this mapping, then one can get alpha I of alpha I times y plus qi x minus alpha I times y dash minus q I of x, because no change in the x. This is a with respect to the second variable is contraction, therefore, there is no change in the x, we are changing the y and checking the difference. Now, this one can get if you are taking alpha I y plus qi x minus alpha I of y dash minus qi of x. Now, this qi x will cancel, then we have alpha I y minus alpha I y dash. So, this we can write modulus of alpha I times y minus y dash. Now, you can compare this Fi is a contraction with respect to the second variable. Therefore, while constructing this one, we obtained this result, that means Ri is lies between 0 and 1. Now, for this form in the equation 2, we have take Fi is this form. Therefore, here alpha we are getting the difference between 2 point when acting on the Fi, we are getting this result. If you are comparing these two things, then one can get alpha I equal to modulus of Ri. So, if you want to make this Fi is a contraction mapping, because if Fi must be contraction, then only the iterated function will be formed and we can get the unique attractor. So, if you want to make this Fi is a contraction, that means Fi defined on this form is a contractant, this alpha I, that means this modulus of alpha I must be less than 1, that means less than 1, because Ri is greater than 0 and less than 1, it must be less than 1. Therefore, we are taking this alpha I is less than 1. So, this alpha I, so what is the role of this alpha I? It controls the, that means it contract the y direction. If you take any 2 points, it is the original points if you are taking, while applying this one y1 and y2 if you are taking, when you are applying that mapping Fi on this mapping, then obviously it will contract like this one. This is after contracting yi y2 after applying on Fi. After applying of Fi, one can get this form y1. This will come to here and will to come. If F acting on this way here, Fi is acting on here, it will come to here. I just notated this one as like this form, so that this alpha I must be less than 1. This is control the data in the y direction. Therefore, we can call it as this as a vertical scaling factor. So, with respect to the alpha I, so it varies from alpha I, it is less than 1 and greater than minus 1. By varying this one in between minus 1 to plus 1, we can control the points in the y direction. Then what is the role of this Qa of x? Here the AI is contract the data points in xi, yi is data point, it contract the interval, the whole interval in the sub interval in the x direction, and bi is just shifting the interval to the right or left. Likewise, here the qi is a function from I to r, is a suitable continuous function. It must satisfy these two conditions. First of we check why this qi must satisfy these two conditions and what is the role of this qi. Let me use alpha I of y plus qi of x, maybe this slide I will use. Here we can check what is the role of this qi. So, qi must satisfying this one, because Fi of x1 comma y1 we must get xi. So, in this form, if you are taking Fi of x1 and y1, which is equal to alpha I times y1 plus qi of x. If you are choosing qi like this one at the beginning point, that means alpha I y1 plus yi minus alpha I y1, so that this term will cancel, one can get yi. So, for suitable choice of qi, this will join the end points of this y direction. Sorry, this one is not xi, this is must be yi. And similarly, if you are taking fi on xn and yn, then this must goes to I plus 1. So, in similar way, if you are taking fi of xn and yn from this form 2, then one can get I alpha I yn plus qi of xn, it is 1 here, and qi of xn. So, which is equal to alpha I yn. Then what is the necessary in imposing this condition, so that plus yi plus 1 minus alpha I yn, then this term will cancel, one can get yi plus 1. So, that this q must satisfying these two condition, so that the fi will satisfy the n point condition. So, what is the use of this one? Here alpha I contract the points in the y direction, whereas this qi acting similar role like bi, it will bind the data point, so that all the data, the curve will passing through the data point, it will connect the points, there will be no discontinuity. So, this is the role of qi. Fine. If you are taking alpha is 0, if you one can take alpha is 0, what is the effect? There is no effect on the Li, because it does not depends on the alpha I. If you are taking alpha I, then one can get qi of x, that means fi of f function is fully depends on qi of x. That means there is no contraction in the y direction, just it will bind the data points in the y direction and it will bind the data points in the x direction. Finally, one can get to the classical interpolation function. If you take 2-3 data point, it will goes like this one. So, if alpha I equal to 0, then the fractal interpolation function g reduced to the classical interpolation function, which can be described by the choice of qi. If you are taking qi is some similar like this type of function cix plus di, then it is just a linear function, just connecting the line between 2 points. Therefore, the fractal interpolation function will be considered as a generalization of classical interpolation function, as if one can take alpha equal to 0 in this form of fractal interpolation function, that fractal interpolation function reduced to the classical one. So, the fractal interpolation function will be considered as the generalization of classical interpolation function. Now, we will discuss the functional form of a g. As per the theorem 1, g is obtained as the unique fixed point of the function phi defined in the theorem 1. The phi function is defined as phi of h is defined as fi of Li inverse of x, comma h composition Li inverse of x. This is the form of phi function. So, this g is obtained as the unique fixed point of the operator phi. Therefore, phi of g one can write as g, therefore, one can get this equation. Now, we are taking Li fi in the form in the previous equation. Li we are taking as Li of x as aix plus bi, and this fi we are taking as fi of x comma y we are taking as alpha I times y plus qi of x. Now, you can replace this Li in this fi with this form, then g of x one can get g of x, you can replace this f with this form, then here it will act as x, this will act as y. So, alpha times y g composition Li inverse of x plus qi of x is Li inverse of, this is the x. So, one can get Li inverse of x. Now, if one can take x as Li of x, if you take x as Li of x, then alpha times g of x. So, this Li because Li is the contractive homeomorphism. If you are composite with this one, you will get the same x, that means identity function, plus qi of x. Now, we have the fine form of the fractal interpolation function as like this one. You can see here g alpha I and g of x is the fractal interpolation function, plus q of x is the controlling parameter which bind the data points. Alpha is the vertical scaling factor which controls in the y direction. Therefore, the fractal interpolation function satisfying this self referential equation, therefore, one can get the form of the fractal interpolation function in the form of like this one. That means, the fractal interpolation function will satisfying this functional equation. Here, the choice of function qi determine the nature of fractal interpolation to be an affine or non-affine fractal interpolation. As I mentioned, this alpha I controls the curve in the y direction. This qi bind the data point with that means bind all the data points. It means when you take alpha is 0, if alpha is 0, this term becomes 0, then the fractal interpolation function fully determined by qi of x. So, by the nature of qi of x, we can say the function is affine function or non-affine function. So, if you are taking the qi as a linear function Cix plus di, then g is referred as linear fractal interpolation function or affine fractal interpolation function which satisfying the functional equation in the gi of x. Here you just replace with Cix plus di. So, one can get g of Li of x equal to alpha times g of x plus Cix plus di. And similarly, instead of this affine form, if you are taking qix equal to in the form of x square plus Cix plus di, one can get the non-affine forms of like this one. Here qi is the quadratic polynomial of the form, this one, the particular case of quadratic polynomial. Here the leading coefficient we are taking as 1. I will explain why the leading coefficient we are taking as 1 while estimating the parameters ai, bi and ci and di. Then g is referred as the quadratic fractal interpolation function satisfying the functional equation, this one. Instead of Cix plus di, we are writing x square plus Cix plus di. So, based on the nature of qix, we can define the fractal interpolation as, or we can call the fractal interpolation as linear fractal interpolation function, quadratic fractal interpolation function when qi is the quadratic, particular case of the quadratic polynomial of the form like this one. And one more special case, when you are taking qi as q as a function of g composite Lix minus alpha of b of x, we can call it the alpha fractal function. So, with respect to the qi, we can classify the fractal interpolation as the linear fractal interpolation function, quadratic fractal interpolation function and alpha fractal interpolation function. This is a very particular case which we will discuss in the upcoming lectures in detail about the quadratic and alpha fractal function. Now, just you can look the form here. Now based on the QIX, we classify the fractal interpolation as linear fractal interpolation, quadratic and alpha fractal interpolation function. But this, what is the role of this one? This contract the points in the y direction or control the y directions. Now this alpha I, if we are choosing some special case, we can get some smoother approximation that I will explain now. Suppose alpha I are Lipschitz function defined on I. So where I is at the closed interval x1 to xn. Alpha is a Lipschitz function, means if you are finding the subnorm, it must be less than 1. Then you can see instead alpha I means alpha I of x is a Lipschitz function. Alpha I is a Lipschitz function defined on x1 to xn. That means I here it is defined with the maximum value is less than 1. Now the same mapping Li and Fi, we are expressing this form. Now in the previous equation, instead of alpha I y plus qi of x, we are replacing this alpha I with this function scaling. This alpha I is control the data in the vertical direction. If you are fixing one point x, then it will control the data points. If you are fixing the one point here, if the data point is here, if you are multiply with the alpha, it will be reduced to this one. Maybe this is the length of this line, here to here is L. Then if you are multiplying this one, it will come to alpha times L. Whereas suppose for this interval, if you are taking any alpha, if you are taking here x1, it control like this one. If you are taking x2, if you are using this scaling, the constant scaling, again this will reduce this line also alpha times L. So it will comes like this one. Whereas if you are changing any point in this interval, throughout this interval, this alpha is constant, there is no change. Now the smaller difference, the alpha I is Lipschitz function defined on this interval. Whenever you are changing the x value, here the scaling is different. That means if you are taking x1 here, x2 here, for example I am taking two lines, this is y1, this is y2, with assume that both are in the same height. If the height is L, if you are applying this function scaling, then this alpha of x will act with respect to the x value. Assume that this x1, x2 are not equal. Obviously x1, x2 is not equal because we are taking x1 is strictly less than x2. Therefore here if you are applying alpha I of x, then alpha I of x1 will multiply this L and reduced accordingly with respect to the x. When you are taking this as alpha I of x2, then this alpha I of x2 multiply with this one and reduce the line like this one. So this may be the height of this one may be different. So this alpha, that means this vertical scaling factor acting according to the point x, whereas here whatever the point you are taking from this interval to this interval, this alpha is constant. So throughout this interval, this alpha I we are taking as a constant. So this is the difference between this scaling and this scaling. Therefore we can call this as a constant vertical scaling factor. This is the functional or variable vertical scaling factor. So again this functional vertical scaling factor also obey the self-referential equation, this one, since g of Li of x in the constant scaling, it follows the alpha I of ga of x plus qi of x. So, instead of this constant scaling, we are just replacing with the alpha of x. Again noted that this maximum value we are taking as 1, therefore, the attractor still exists for this functional scaling. So, the constant scaling and functional scaling, the difference is the constant scaling throughout the interval it will behave like the same, whereas in the continuous variable scaling, according to the value of x, it will controls the data points in the y direction. So, now we have classified or find the importance of the alpha I and qi. Now, we have the two mapping Li of x equal to Aix plus Bi and Fi of x comma y equal to alpha I times y plus Qi of x. Now, all these parameter Ai, Bi, alpha I and Qi are classified. Now, the question is how to determine all these parameter, so that we can find according to the data point how to determine all these parameter values, so that we can easily generate the fractal interpolation function for the given data point. That we will discuss in the next lecture. So, the next goal is to find the unknown parameter using the endpoint condition of Li and Fi. Thank you. The few reference is given here.